Good afternoon. I'm Tom Tobin. I'm the founder of Modelshop. I'm joined by James, who's an analyst for the company. James has a pretty ambitious demo scheduled for this afternoon, so we're hoping the demo gods continue to be with us. So Modelshop is a platform that allows you to very rapidly deploy analytic decision engines. So what exactly is an analytic decision engine? If you look on the whiteboard, there's some pretty sophisticated math up there. Does anyone recognize the formulas? Differential equations. I have a free pen from Modelshop if anybody can come up and tell me exactly what's going on that whiteboard. But I hate to disappoint, that's not what we do with Modelshop. We do not build analytic solutions like that. What we do is we deploy them. We take analytic models, we surround them with computational engine, a very powerful ontology engine, data integration, and we deploy a decision solution, an engine, into production environments, typically real-time environments, high-volume environments. So these are some of the solutions that we have deployed with Modelshop. You can see that they're typically mission-critical focused around the types of problems that they're solving. We've had a lot of success with credit origination, so many of our early customers are in the credit space. In fact, one of our customers is a fintech called Blinker, and we have a marketing agreement. We can talk about them. They were recently cited at South by Southwest as one of the most innovative fintech companies around interactive innovation. And what they do, if you get a chance to check out their application, they do private party selling and buying of autos with a financing wrapper around it. And they do the whole thing on the phone. So you take a picture of a license plate of a car, you take a picture of your license, and they facilitate the entire process end-to-end through financing and closing of a loan. And the engines behind the scenes are all Modelshop. So pretty powerful engine. We've solved some pretty interesting problems. But we're not limited to what you see on the screen here. What's unique about what we do is it really allows you to deploy custom solutions. So if you have a vision for how you want to take data, combine it with analytics and decisioning, and deploy a process, Modelshop is a perfect platform for that. So a little bit about how it works. You may say, look, I already do that type of decisioning in my enterprise already. We have tons. In fact, we have too many of those decisioning systems. And that's exactly the problem. So there's a lot of friction that happens. You have knowledge workers who are working with desktop applications. They might be using spreadsheets or doing some Python scripts, typically kind of in the back room doing decisioning, analytics. They might be doing pricing optimization. They might come out with, new instrument models. Then you have enterprise software. So this is where you've automated things. You're doing potentially fraud detection. You're doing portfolio optimization, credit origination in real time, transactions, trading. So you're making lots of decisions in that enterprise software. And then more and more, you're trying to bring your customer touch points into the equation. So like the Blinker app that we described, you're trying to get the consumer involved where as they put data into the system, you're making decisions in real time, on demand. And there's a lot of friction between all these different layers. And that's where Modelshop comes in. So we have the ability to deploy these common decision engines as a set of services, REST API-based services. We have lots of other different ways of getting in and out of these decision engines. But we now have consistency by having a single set of decisioning that happens as a central service. You can plug it into all three of these environments. So we've plugged it directly into spreadsheets with queries coming out of spreadsheets, directly into real-time sub-millisecond transactions, as well as into front ends. The other value with having this middle layer is you'll see when we do the demo, business analysts can own these decision engines. So they have the ability to maintain logic, deploy changes very quickly. It creates a sense of agility that organizations haven't historically had. And then finally, since we have a very powerful data modeling engine, an ontology engine, we have the ability to pull in new data sets very quickly. So we've integrated with some of these data sets, not all. We integrate with, obviously the bureaus, car, vehicle valuation reports. And we've designed the system to be as close to click, click, integrate as possible. So I know this is a tech conference, probably enough slides. What we're going to do is James is going to go through a demo of creating a complete credit decision engine from scratch. It's going to be a simple credit decision engine, but it's going to be complete. We're going to do this without a net. I think we do a backup video in case something goes wrong. I think I just jinxed us. But James is going to go through. He's going to import some application data, including detailed Experian credit reports. He's going to then create an ontology. He's going to link together all the information, and that's a big part of the power of the platform. Create a set of variables. He's going to deploy a logistic regression model. And then he's going to activate a rule that says, based on a strategy, whether or not we're going to approve or decline and at what rate. So he's logged into Modelshop, and so you can manage these models. They're almost like documents, but this is multi-tenant, shareable. It has security around it. So when you get into a model, James just created a new one. First thing he wants to do is import some data. So he's actually going to go to an Excel file to start and pull in some application data. So we have applicant, application information, address, and we dissect the Excel file. We can pull features out of it. We can go to table level information. We can even pull in some equations from Excel. We have a love-hate relationship with Excel, and I think it's really important for our application to work well with it. Next, he's going to pull in some Experian credit reports. So we'll see how good the network is here. It's about a 40 meg, so not a big file, but it's got to go over the network. So all he has to do here is put in some XSDs. So directly going to the Experian website, pulling off the XSDs from Experian allows us to decode the detailed XML reports. And what's happening is under the hood, the model is building Java code that manages all of this data. And in fact, anytime we add a variable or a calculation, it's generating a combination of Java and Groovy code under the hood in real time, and then coming back with a runtime Java engine. So, network. I think if people get off their phones, it might move a little faster. Let's give it a second. We can pull in data from a variety of sources. We can pull in from databases, any sort of XML, JSON, either from web services or from files. In fact, that's a typical mode where you start with a file, it inspects it, it generates a schema from that, and then you just point it to a web service from there forward to have a real-time integration. And
hope the network will be faster.
There we go. All right. So interestingly, Experian reports are very boring when you first look at them because it's a detailed structure. So James is going to drill in. You can see all the products, and we have trade lines and payment patterns. And I don't know who's worked with credit detail before, but it can be fairly complicated. But what we do, our philosophy, is to pull data out. It's almost like a ELT versus ETL. Or data lake, or there's lots of different paradigms. But the idea is we have the data in its raw form. We use variables to go in and get it. So James is going to create a handful of variables here. He's going to create a social security number, FICO score, and total debt. And as he starts entering here, you can see this is our language, Groovy. It has autocomplete, so it's very accessible to a business user. It understands the schema. He's going to cheat on the next two because they're not quite as simple. This is where we're using closures, for example. Once he does one of these here, we'll jump in and take a look.
All right, so I screwed that up.
But this language, fully accessible and allows you to really connect information and extract information out of the detail as you pull together this model. And you might think it looks a little coding and scripty, but we've worked with, for example, risk analysts that have done a great job. Initially, they look at it and say, well, that's like coding, but it's really not. It's like scripting. And it's much easier to understand than something like a VLOOKUP, for example. So we've pulled in some data. And what we're going to do next is we're going to start building this ontology engine. So we had FICO score. We had all this stuff in the credit. These are all the other tables that we pulled in, or record sets that we pulled in. And James is starting to link them up on keys. Now, one thing that's unique about Modelshop is keys don't have to be hard keys. Any calculation in the engine can drive a relationship. That's why we call it an ontology engine, between different entities. So, for example, we're going to link some things on FICO score. FICO score was a calculation that came out of the depths of that XML document. We can use that to link. It doesn't have to be a hard link. We could do more interesting things. We could do risk segmentation. And we could use that risk segmentation score to link entities directly and traverse those links as part of our calculation engine. And if the risk profile changes, that link will change in real time. So it took a lot to really get that engine to be able to do that. But in the end, when you're done, you have, it kind of still looks and feels like Excel, but we have more sophisticated data models, we have entity relationships, and we can start to transcend all of that to build our models. So James is going to go through and do a few more things. One thing he's going to do is use that FICO score to connect to a strategy record that we described. We actually snuck that in when we imported the application data. We also imported a strategy. So you can see how the kind of the being able to move through the different entities and their relationships is really simple. So applicant to the credit report to the FICO score. So now we have a FICO score. He's now connecting the strategy up based on the FICO score and the calculation that we just created. So it's all starting to come together. Next, I'm really putting him on the spot here. He's like sitting doing this live. But so next, James is going to go through and create a few more variables that we need to make a decision. So pulling more information up, he's going to calculate a rate. The rate is actually coming from that strategy. And then we're going to turn that into a payment using a typical calculation, just like you see in something like Excel.
If I could spell.
Give him a few minutes, a couple of minutes to get this done. So kind of stepping back and looking at this, what we're doing here is pulling together all the information that you need to make a real-time decision based on analytics, and from there, rolling it up into ultimately, we're going to put a logistic regression model in here and have that kind of do our segmentation scoring. Just a second.
Let's do some formatting.
Trying to get some of the types correct here. So what do we? So we have FICO score, strategy rate, the payment, and DTI. So debt to income is a typical ratio that impacts a credit score or a risk score. So what's really powerful about this environment is, like Excel, I don't know what people think about Excel, but one thing that's really powerful about it is every time you do a calculation, you see the results, and you continue to build this model over time. So this is where business analysts can start to add, and over time create fairly sophisticated models that ultimately make decisions. All right, James is now adding a probability of default. So we're going to cheat a little bit. So here we're in R Studio. And made it clear from the beginning, we work with R, we work with Python. We have embedded engines, so we run containers, both Python and R containers, so that you can natively run those analytic engines as part of your deployed decisioning process. James is actually cheating here, and he dropped the logistic regression model directly into a calculation, which works as well. And if you come by our booth, we'll show you the tighter integration with those analytic engines. All right, one more calculation. We're going to now do a calculation that predicts the potential profitability. So you give it a second. So this is a simple calculation based on payment term, loan amount, and an aggregation of the probability of default. So what we're getting is now an expected. Go ahead. We're getting an expected profitability for each and every loan that we're trying to decision here. Let's take a look at this a little more visually. We're going to run in and do a quick cube. So cube is like a pivot table, or like a cube in sort of a BI environment. The difference with the cubes in Modelshop, a couple of things. We could do natural binning, so you can't really do that very well in something like Excel. You could certainly do it in R and Python. But it's also a real-time cube. So I think he's going to add a fixed width bin here so we can look at it a little better. It's a real-time cube, and this is really powerful. So Modelshop can be deployed as an event stream decisioning engine. And for applications like fraud detection, for example, looking at real-time event streams and having it update an aggregation number in a cube format is really powerful for detecting outlier events. Throw a quick graph in here so we can see what it looks like. So you can see that the distribution the distribution of profitability is a little higher on the lower credit grades, but we can get a kind of sanity check here. Finally, we're going to add a quick rule. So this is where we're actually making a decision. We are going in and saying if the I did say at the beginning that we had an ambitious demo, didn't we? We warned you. So he's doing a calculation based on the strategy and the profit from this individual loan and deciding to either approve or decline an application based on whether that rule fires or not. And when he saves it, all rules are updated automatically. This is as close to a stateless engine as what we could create. So it's always recalculating dependencies. And let's go. Is the graph there? No.
Yeah.
All right. Go to the dependency map.
So here we'll see that there's trues and falses.
OK, so people are approved or declined. And as we're creating all this, we're keeping track of all of this. So we just created this just now. Right? These are all the fields and the calculations and the relationships that have been created with the expressions that we've been building. And this is incredible from an audit perspective or from a rating agency perspective to understand what's the risk in the logic that you've deployed. So I'll just switch to the deck. So what we'd like to do is invite you. Go back to the deck. James is going to deploy a Postman call to that model very quickly. So we can call APIs, we can get responses. The APIs are immediately available for the model that we built. So as we build models that exposes APIs, you can get results back for testing. Typically, you go through a deployment process before you go into production. So what we'd like to do, that was a very simple model. Didn't seem that simple, but it was a basic credit application. But what we'd like to do is invite you all back to the booth and take a look at some of the more sophisticated models that we've built. This is in 15 minutes. Imagine what you could do with a week of building these models. We can demo some of those in a handful of different use cases. How are the rules versioned? So they're source controlled. In the back, we have Git. So they're actually XML documents for all the model configuration, and Git backs that. The UI, we didn't show you this, but has the ability to do versioning as well based on that information. So you can see deltas for every change. You can see who made the change, and you can actually back things up. Other players in the market, our value proposition. Interesting, we talk about modeling, we talk about analytics. There are a lot of vendors in that space. In terms of automated decisioning, the top vendors, FICO, IBM, there's a handful, business rules engines. And what they have not done, in my mind, because I worked for 3 of them in the past, they have not brought the business rules, the analytics, and the data integration together into a single platform and made it accessible to business users. I think that's our top value proposition. The infrastructure underlying. So it's an in-memory engine. We cache off to a data cache. So this is not database of record. We are continuing to look at technologies that can be fast enough from a calculation perspective to try to push some of this off of memory. But typically the technique is we can stream data through the engine very quickly. We don't have to hold on to it in memory. Anything that we need to access from a calculation perspective is a memory-based piece of information. We're continually caching off to disk so that we can recover and bring models back. Other than credit risk, what are some of the other use cases for the tech? And are they just as quick to build? Yeah, so what we just built had nothing to do with experience in credit. It was completely from scratch. So we can just as easily pull in investment data. We can pull in fraud information, transactional information. We're very good also at cash flows. So if you're trying to do something that's doing Monte Carlo simulation and cash flow projections, it's very quick to build those in Modelshop. OK. Well, thanks very much for your time. And like I said, stop by the booth. We'd love to show you some more models.